the little fellow here. Oops. Are these Japanese or Vietnamese mangas? Yep. Korean. Okay, I'm completely okay. I see. Okay, good.
Yeah, there's still 75% left, so I think
Okay, super. Thank you very much.
it's enough.
Thank you.
Thank you.
So you see, I'm not completely up to date in these respects. Now. Sorry about that. I think it's just to go on.
I think because there's a small part of it is already broken, that's why. So just like
Okay,
this.
very careful. Okay, thank you very much. So let me try again. No, that's fine. It's just always a little bit of an experiment to fix this here. But I think now I'm safe. Okay, good. All right. Okay, so let's interpret this. Now, that's actually what I said before the break. On the left-hand side, we have the marginal return investing in physical capital. On the right-hand side, we have the real interest rate, which is the marginal cost of borrowing, but also the marginal return on lending, which would be the opportunity cost of investing. And the story told by this equation is a very simple one. You invest up to the point where it's worth it. And how you know it's worth it? Well, you invest up to the point where you say, the cost of borrowing is exactly equal to the marginal return. So as long as the cost of borrowing is lower, then you increase your investment. Now please note, and this is where diminishing marginal returns come into, or marginal productivity comes into play, this becomes lower and lower the higher the capital stock. So it's really about, that the KT plus 1, this is the right-hand side of the equation, this is R, and this is how much capital you want to have. And you see the right-hand side being here, this thing. And you also see that exogenous changes in the interest rate have an effect on how much you want to invest, because if the interest rate goes up, then the optimal capital stock goes down and you will invest less. And if the interest rate goes down, then you want to move in this direction. So you have this effect of the real interest rate, which is given on international financial markets, on domestic investment. So if the interest rate is low, firms will invest more, and if the interest rate is high, firms will invest less. That's a very simple insight. Now, equations 317, 319, and the intertemporal budget constraint define the optimal time paths of consumption and investment. Well, that's in fact what we're going to do after the lunch break. Actually, that's to implement that and to crank things out for a specific production function. Now, importantly, and that's also an interesting thing to find, optimal investment is determined by the exogenous interest rate and properties of the production function, but independent of preferences. Right? The optimal investment is implicitly defined by this equation. You don't have any preference parameter here. To put it into simple words, you start by maximizing the cake, and then you decide how to eat the cake and how to allocate it to different periods. Now, of course, if the interest rate were endogenous, if you had a closed economy, then things would be more complicated, right? In a closed economy, the interest rate is endogenous. In an open economy, it's given by world financial markets. So you can say, given this interest rate, which is set by something beyond my control, how much do I want to invest? The optimal consumption path is determined by preferences and the world interest rate. So you maximize the cake by choosing the optimal investment, and then you determine the optimal time path of consumption, or you maximize the present value of income by choosing investment optimally, and then you maximize utility by choosing the optimal time path of consumption. So there's a separation of investment and consumption decision, which is an interesting property of this model. So let me give you an example. And again, we have this little fancy toy example that should sharpen our intuition. Now, the first thing is we assume again that 1 plus R beta equals 1, which has the nice implication that the optimal consumption path is flat. We assume that in period 0, the net international investment position is 0. We assume that the government doesn't spend any money, so it doesn't tax you either. And we assume that K0 is at the steady state level. Now, the steady state level is a situation where basically you can compute the steady state by solving this for K and saying K is just, in the initial stable situation, the capital stock that you want to have. The steady state. The steady state is a situation, well, let me give you an example, because that's also going to be helpful for what you're supposed to do in the afternoon. So deriving the steady state capital stock well, assume that the production function is ys equals as ks to the power of alpha ls1 minus alpha. As equals 1 and ls equals 1 as well. Okay? That's an assumption. So the consequence is ys equals ks to the power of alpha. Okay? Now, this condition says, and optimal investment is characterized by R equals alpha ks plus 1 to the power of 1 minus alpha minus delta. Now, in the steady state, so that's, of course, equivalent to saying r plus delta equals alpha ks plus 1 to the power of alpha minus 1. And that's equivalent to saying ks plus 1 equals alpha divided by r plus delta to the power of 1 over 1 minus alpha. Okay. How did I get there? I shifted this to the right-hand side, shifted that to the left-hand side, and then I took the whole thing to the power of 1 over 1 minus alpha.